All right, 7th graders, we're going to go through lesson 7 on transforming formulas. Transforming means changing, right? Changing the formula so that it is solved for a different variable. And we're going to use formulas that you're familiar with. All right, look at this first formula. The area of a rectangle is equal to the length times the width, right? We know that that's true for finding area. But what if we're given the area and we had to solve for the length? We can transform that formula so that it says L equals instead of A equals. Okay? And we're using the same steps that we used before. How do you get rid of something on one side? How do you remove something on one side? Joey?
By adding the opposite.
Right, by adding the opposite. The same is true when you add the opposite of a variable term. Remember, when we had negative 2y on one side, if we add its opposite, negative 2y plus 2y is 0, right? So we're going to use that to remove something on one side. How do you isolate a variable if it has a coefficient? Let's say, how do you make 2y just 1y?
Like negative 1y to that, and if there's another variable on the other side, you do the same thing.
Okay. And to isolate the variable, you would divide by the number. So if you have 2 y's on one side, if you divide it by 2, then you're left with 1y. Or multiply by the reciprocal, right? Now, we're going to do the same thing, but instead of using numbers, we're going to use variables. Okay? In this example, the area equals the length times the width. If we divide both sides by w, then we get L by itself. Right?
Yeah.
Because the w's cancel out, and you're left with A over W as the formula for the length. Okay? Think about it this way. If the area was 12 units and the width was 6 units, then 12 would equal 6 times L, right? Then, if you divided the 6 by 6, so if this was W, and we divided the other side by 6, we have the formula solved for the length, right? Does that make sense? But instead of 6 and 12, we're just leaving them as A and W. Okay? Nod your head if you're with me on this. Okay?
No.
So, Dylan, if the area is 12 and the width is 6, then 6 times the length equals 12, right?
Okay.
How would we find the length? We would divide 12 by 6, right? Or, to get rid of the 6 on this side, divide it by 6. Well, if this says W, if we know the width is 6, well, we just leave it as W. What are we dividing by on this side? W by W, right? W divided by W. Now look at this formula. W divided by W cancels out the W's. And A divided by W equals L. Okay? Let's go to this example. What if we have this formula? P equals S minus C. Okay? Now this is just a basic addition or subtraction equation. In order to solve it for S, if it says solve this for S, then you would want to get rid of the negative c, right? How do you remove the negative c from the right side? Yeah, add its opposite. Add c to both sides. Now, we can't add terms that are not alike, right? You can't add one p and one c, so we have to leave it as just p plus c. Okay? And that equals s. Okay? Does that make sense? We're just removing the c from this side, or the negative c, I should say, and adding the c to this side. Let's look at this one. H equals k over L. Actually, let me rewrite this one so you can see it more clearly, and I'll show you what to do. This one is very similar to this one. H equals k over L. Now, if we are going to solve this for k, then we have to get rid of the L on the bottom line, right? So how can we cancel out the L? What would we be able to do to cross off the L? Isaac?
Multiply each side by L over 1.
Good. If we put L over 1, then you have an L on the top and an L on the bottom. That cancels out the L's. Right?
Yes.
And that's left, we're now left with K on that side. And whatever we do on one side, we have to do on the other side. So multiply by L. Do we need to put it over 1? Nope. So K is equal to L times H. Or just LH, you could write that as LH. Okay? Alright, so we're going to be transforming formulas on the assignment for today by using those same procedures. Adding the opposite to remove something from one side, or multiplying by its reciprocal in order to isolate the variable. Yeah?
Of what use is this in the world?
Of what use is it? We just went through an example. The area formula. Okay? You will have to multiply, if you know the area is something, the area of this room, and you need to know its length. That's any person who measures is going to use this. So what people use measuring in their careers?
Wait, so we're using variables instead of numbers? Like,
Yeah.
Well, like,
What type of careers use measurement?
Measurementology.
Every type of science, every area of science, every area of construction, every area of
Philosophy, I think.
no, maybe.
Philosophy.
Wow, what's your measuring methodology? I don't even know.
So any career that uses measurement is going to use
Area graphic
needs to know
studies.
this stuff. Okay? Hunter.
Alright, I challenge you to find a real world use, a legit real world use for every single thing we learn.
And I'd be happy, challenge you then to be able to do everything that I find.
oh dear.